much more folio. Counting problems. So the problem is counting the number of students, always low. Counting problems. This puts it all together, right? So you need to figure out in doing these problems, should I use the fundamental counting principle, right? Put down a blank for each of the things and the number of choices in each blank. Should I do this as a permutation? Is it a permutation with a repetition? Or is it a combination question? Right? And so we'll just run through some problems and discuss, okay, you could do it. And if there's various ways of doing it, I'll show you various ways. And the reason for that is that the answer may not be given as just a number, right? The answer may be given in combinatorics form. Now at that point, if all you can do is come up with a number, you might just have to work through each of the solutions and say which one of these, but there might be two, give me the same number, and if there are two that give the number that I think is correct, then which one of these is correct, right? So is it a combination or is it a permutation? That's what you're asking yourself. Okay, how many different possible sets of answers are there for 28 multiple choice problems? Okay, so on the diploma exam, there are 28 multiple choice problems. How many different sets of answers are there for 28 multiple choice problems? And we will go with the default, right, which is what we understand a multiple choice problem to be, which is A, B, C, D. Okay. Now, if you're in the States doing SATs or stuff like that, they always have A, B, C, D, E. Okay. We don't. So just our standard multiple choice problem. Okay, how are we going to do this? Is it a combination? Is it a permutation? Is it none of the above? So, how can we tackle this problem? But make sure they're looking before you throw it. Nice. Good throw, good catch. Okay, here's what we're going to do. We are going to write down 28 blanks. This is not a combination, it is not a permutation. This is a fundamental counting principle. There are 28 questions. So how many choices are there for the first question? 4. Second question. 3rd question. 27. 28. So what's that equal to? How many 4s are there?
28.
So it's 4 to the power of 28. What's 4 to the power of 28? How large?
Fairly large.
So I got like 7.205 times 10 to the, is that a 16?
Yes.
Okay, because I can't read my writing. Small. 7.205 times 10 to the power of 16. So what's 10 to the 9th?
7
Billion.
billion.
10 to the 12th.
Trillion.
10 to the 15th.
Quadrillion.
So this is 72 quadrillion. That's a big number, right? Big number. So they have software that goes through all the multiple choice when it's run and it says, hey, these two answer sheets are very similar. Matter of fact, they're more similar than they should be. And then they'll say, so did these kids go to the same school? And the answer sheets are more similar than they should be, and they were written in the same place. So they'll look to see, well, where were they sitting? Oh, one was sitting in front of the other. Okay, well, then there's a problem, right? So it's called collusion.
What
So
if it's a coincidence?
could well be. Now, generally what they're looking for is not 2 kids that scored 100% on it, right? Because then the papers will be very the same. But they'll be more interested if, hey, 2 kids both got 28 or 28 multiple choice questions right, but one kid's going in with 35%, the other kid's going in with 95%. We think there could be a problem with the 35% paper that they should not be getting 100% on this. The 95, yeah, okay, they get 100, so what? We expect that. What they're more really looking at is the wrong answers, right? It's the pattern of wrong answers. They'll look at that. So if there's 10 different wrong answers, you're still looking at 4 to the power of 10, which is a really big number for the number of possible answers. And so they're looking at, yeah, you know, look, they got these 10 questions wrong, and they had the same wrong answers. We're going to look and see, right? We're going to look into this. Because, you know, what's the chance of that happening? Not very high. All right, so that's a fundamental counting principle problem. Then we have combinations, and you will get these formulas. And we have permutations. Formulas, right? So we have these two formulas. And the formula may come in handy, right? And we also have keys on our calculator to do this, right? You just got to make sure you know how to use the calculator. If you want to do 12P5 or 12C5, then, you know, how do I do that? But you also have to know how to expand these, right? So if I see 12 choose 5, then I write 12 factorial over 12 minus 5 factorial times 5 factorial. The difference between these two formulas is this little r factorial there, and what's it doing? So why is that there and not there? What's the purpose of dividing by r factorial? Who can outlast who? When does the silence become uncomfortable? Finally, I blurt out the answer. What can wait you out? What do we do when we divide by r factorial? Well, you think about it. I'm going to go answer. Hello? Yes. Sure. For any particular All right, we're leaving YouTube hanging here. So why divide by r factorial? Why the difference? What's the difference between a combination and permutation? Let's back up a little. Whether or not there's order. Okay, so which one the order doesn't matter? Combination. What is r dividing by r factorial going to do? It's going to take out the order, right? It's like phoning for Chinese food. You take out the order. It's not at all like that, but I couldn't resist. So this takes out the order, right? So if we're interested in ABC, we don't care if it's ABC, ACB, BAC, BCA, or CBA, right? We don't care about the 6 possible different orders. In a permutation, we do care, right? ABC is different from BAC, and so on. In a combination, we don't care. I think combination is just your dealt a hand of cards. You don't care what order the cards come in. You're going to take that hand and arrange it any way you like. You know, do I want to put all the face cards together? Do I want to rank them in rank order? You know, stuff like that. Okay, so what if we give you NC2 equals 21? And I ask you to algebraically determine the value of n. So, number one, you can use your calculator to figure out what n is, right? You just go y1 equals nc2, x c2, and then you go into the table and you look and say, oh, I know it's 7 or whatever it is. Now, how do I do this? So here's what you do. You look at the formula sheet, right? And you just say, okay, it's n factorial over n minus r, but in this case, r is, this is n, this is r, so n minus 2 factorial, and then r factorial 2 factorial, and that's equal to 21. Okay, step one, what do? Multiply both sides by 2. Factorial, which is really just 2. Okay, so we've got n factorial over n minus 2 factorial is equal to 42. Right? Now, to ask this particular question on a diploma, I can't say algebraically determine because we can't have you doing work, but we can show you a solution and say, can't have you doing work, can't have you showing work. So we can show you a solution and say, well, where's the error, right? I'm just guaranteed there will be an error. Which step does the error, which step does the first error occur in? In which step does the first error occur? Arrow? That's wrong. Is there a new one tonight? New arrow? Wednesday? Should be, right? Okay, n factorial over n minus 2 factorial. What do we do with that? Expand. Which one do we expand? The top or the bottom? Okay, the bigger one, which is the top. Okay, so you tell me when to stop. Oh, okay. And that's your stop sign, right? An exclamation mark. And that's equal to 42, right? But we get to cross these guys off. So now the left side becomes n squared minus n is equal to 42. And this becomes n squared minus n minus 42 is equal to 0. Which factors to n minus 7, n plus 6 equals 0. Okay, so you run through the solution. So on Monday, you're going to have to do one of these. At least one like this. So this is the situation, right? You just set it up, multiply both sides by whatever number. If that was a 3 factorial on the bottom, then that would become a 6. I'd multiply both sides by 6. Okay, n is 7 or n is negative 6. It can't be negative 6, right? N must be a natural number, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. It's actually got to be a number bigger than 2, because you can't say 1 choose 2. Right? Can't do that. Try it on your calculator, it's going to give you error. You have one item, you want to choose how many ways can I choose 2 of them? There's only one item. You can do 2 choose 2. Okay, questions? Let's try a variant. N plus 3 choose 2. So there's some back. Now, you could do this, right? You could just go change the n. You could say like, I don't know, what's a good letter? M choose 2, solve for m, and then just back it up by 3, right? Just say, so if m is 10, then n is 7. So you could do that, right? That's a possibility. Solve a simpler problem. Say, I don't want to do n plus 3 choose 2. I'll just do m choose 2. I'll get m. I'll say, but that's the same as n plus 3. What number do I have to add 3 to get this number? But let's do this. So the idea is you're just substituting into the formula. Right? So n plus 3 choose 2 is this number factorial over this number minus this number. Too many brackets there. Factorial, r factorial, right? So this is n and this is r in the formula. So this is n factorial. It's the first thing factorial. It's n minus r, n plus 3 minus 2 factorial, and then 2 factorial. And that's equal to 28. Okay, I'm going to do 2 things at once here, right? So I'm going to leave the top. It's n plus 3 factorial. N plus 3 minus 2. What's n plus 3 minus 2? N plus 1. And I'm going to multiply both sides by 2 factorial, which is 2, giving me the 56. So we take the larger expression. What's bigger, n plus 3 or n plus 1? N plus 3. We expand it. N plus 3 times n plus 2 times 1.
Stop.
Where?
N plus 1.
Okay, good. Okay, this is n squared plus 5n plus 6 is 56. Subtract 56 from both sides. Find two numbers that multiply to 50 and differ by 5. One is positive, one is negative. The bigger one is positive, gives you a negative. Cross that off. And n is 5. You want to check that. Wow, we pulled it. Click, click. It's a bit of a, yeah, you're slapping in the face. Well, I just kept going. Your hand wasn't there to block me. So n is 5, right? Which means if you do 8, choose 2, right? It was n plus 3, choose 2. N is 5, 8, choose 2. Check it. You do that on your calculator, choose 2 is 56. Okay, good. Yeah, it works. Right? I mean, another way, if you don't want to graph it, you could just sit down and plug in numbers for n, starting at some reasonable number, and just keep going. Right? And if it's too low to begin with, then you started low, and you got to keep going up. And if you decide, hey, let's try 10. So I got 13, choose 2. Ooh, way too big. Okay, let's go to 5. So I got 8, choose 2. Oh, that's it, right? I mean, I found it. So you don't have to graph it. You could just plug in numbers. It's never going to be something like 300, choose, 87 or something. So the number won't be that large that you couldn't just, that method would be called brute force, right? I'm just going to keep trying numbers until I find one that works. Just brute force it. Right? I mean, it's multiple choice or machine scored, so nobody knows how you did it. They don't know that, hey, I tried 15 different times before I found the answer. Right? The question is, did you find the answer? All right, yearbook committee needs a group photo of 6 girls and 4 boys. The yearbook committee. There's a lot of committee work in this permutations and combinations, right? There's different ways to choose them. Needs a group photo of 6. The yearbook committee needs a group photo of 6 girls and 4 boys. They go to the foyer where there are 8 girls and 8 boys. They're all weird questions. Like the one about Sally goes to the store and buys 50 watermelons. Like, what is Sally doing buying 50 watermelons? Okay, how many different groups of 6 girls and 4 boys could they take a photo of? So A, how many different groups of 6 girls and 4 boys could they take a photo of? Probably should be a digital image, but whatever. We'll use old words. Photo. We'll gather them around a phonograph. A phonograph, not a photograph, a phonograph. Sometimes known as a record player. But what's a record? Oh, who's into vinyl? Somebody's got to be into vinyl. Like maybe one. All right. 180 gram vinyl. It's the best. Analog, not digital. Continuous. Well, unless you get into 196 kilobit sample rates, right? If you up your sample rate and stuff, you get closer. Anyways, that's gonna have to do with it. How many different groups? So, does the order matter? No. Okay, so one of the questions you have to ask yourself is, does the order matter? If the order doesn't matter, then this is a combination. Okay, so what are we gonna put? What's the answer? How many girls are there?
8.
How many do I need?
6.
How many boys are there?
8 boys.
How many do I need? So it's 8 choose 6 times 8 choose 4. Which is 1960. A good,
Did that in
huh? Part B, or question B. If they decide to line the students up in a row with the girls first and then the boys. Okay, so if we line them up in a row, do you think, does the order matter? Is it a different order if they're lined up differently?
Yeah.
Yeah. So now it becomes not a combination, but a permutation. So it becomes 8p6 times 8p4. Is that going to be bigger than 1960 or smaller? Smaller. It's smaller by this much. Actually, it's not smaller by that much. That's the answer. It's bigger by just a little bit, like 34 million bigger. 33,868,800. Okay, so permutations, if order matters, you get many more possible arrangements, right? Because they're all different. We just have a group photo and you got a group and you don't care about the order. It doesn't matter where they're lined up, right? It just matters how do I choose 6 of the girls? How do I choose 4 of the boys? Here, we're lining up 6 of you. You go first, you go second, you go third, so on, right? So this is a permutation of 6 objects from a set of 8 and of 4 objects from a set of 8. Not that we mean to objectify either girls or boys, but
Whoa.
we can't help objectifying people in this particular unit. So. 3. How many? How many ways can 5 starting positions? 1 center, 2 guards, 2 forwards. What sport could that be?
Basketball.
Basketball.
Oh.
From a roster of 3 centers, 5 guards, and 6 forwards. Okay, so we want to make up the 5 starting positions, right? All of you 5 are going to start. And I need 1 center, but there's 3 centers. I need 5 guards, and I need 6 forwards. Okay, does order matter? No. Doesn't matter. It doesn't matter if you're the left guard or you're the right guard. Okay, so what's the first thing we write? Order doesn't matter, therefore it is a combination. So the first expression is? I need one of these. So what's the first expression? 3 choose 1, right? I have 3 centers, followed by 5 choose 2, right? So 3 choose 1, so I need 1 center and 2 guards, and what's next?
6 choose 2.
6 choose 2. 3 choose 1 is 3, 5 choose 2 is, remember there's 10, and 6 choose 2 is 15. So there are 450 possible combinations, right, of players that can make up those 5 starting positions. Like coaches get paid the big bucks and get fired regularly. I think Bob Hartley's probably safe for another year or two. Yeah. He's pretty safe for eternity. 4. How many different 5-card hands? Okay, so if ever you see cards and they don't specify anything else, then it is a standard deck of 52 cards, right? If they specify something else, then it'll say so in the question. Like, hey, we're only playing with cards from 7 and up, right? 7, 8, 9, 10, Jack, Queen, King, and Ace. How many 5-card hands that contain at most 2 black cards? Can be dealt from a standard deck of 52 cards. You won't see any card questions on the diploma. Wow, okay, I'm 99.99% sure you will not see any card questions on the diploma. Unless they actually show you a full deck of cards or something. I don't think that's going to happen. Yeah, exactly. With every, you get a deck of cards with every exam. And you can just sit there and be flipping through the cards. And if you're done and the hour isn't up yet, you still got to stay till 10 o'clock, you can just start playing solitaire. I don't know how to play it. Where's the mouse? I have to click on the mouse. How do I move cards with these 2 things? What are hands? Yeah, what are hands? How do I deal this? Okay. At most 2 black cards. How many black cards could you have? So how many black cards? So anytime you get one of these, just write it out or say it to yourself. So that means if I have at most 2 black cards that I could have, how many black cards? What's the fewest I could have? 0. So I can have 0 black cards or 2. Good. So we need 0 or 1 or 2. Or what we don't need is 3 or 4 or 5. Now either way we got to work out 3 things, right? So we need to work out the ways that you can do it. So, how do I get 0 black cards? That's how many black cards there are. How many do I want? Okay, but I need 5 cards, right? So how many red cards are there? Hint, half the deck, which is 26. How many red cards do I need? 5. If there's no black cards, then they are all red, right? So it's 5 red cards. Or, okay, I have no black cards, or 1. How do we do 1 black card? So fill in the rest. You should be able to do this. So just fill in the rest. So that's 0, or, so fill in for 1 black card, or, and then fill in for 2 black cards. Okay, so what goes here? What goes here? What goes here? What goes here? And 1,299,480. So a pretty large number of ways that hand, 5-card hand, could contain at most 2 black cards, right? No black card, or, which is what operation? Or is add, so that's plus, and is multiply, right? So if you look at it, say I need no black cards and 5 red cards, or I need 1 black card. Is that wrong? Or 1 black card and that's why we're multiplying 4 red cards, or plus 26 choose 2. I need 2 black cards and 26 choose 3 red cards. So top numbers always add to 52. That takes into account all the cards that are possible. And the bottom numbers always add to 5 because we need to do a 5-card hand. Okay, question?
Wow, this is good. Are we
That,
done?
that's not a question. No, we're not done. That's a question, and the answer is no. Are we there yet?
Are
No.
we almost done?
Define almost.
Are we there yet?
How many problems?
1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, for you, not for me.
Yeah.
7.
Such a funny joke.
I know, right?
But I like it. Like that.
I wasn't being sarcastic at all.
Why are you talking about
No, she's not. A basketball. Just trying to get Five interested in math here, right? So we throw in some basketball questions.
Oh.
Basketball squad of 11 players. Oh, it's good to increase your vocabulary as well, right? Basketball squad of 11 players is to be chosen. Is to be chosen. From 17 available players. How many ways can this be done if? And then we're just going to have a couple of different questions, right? How many ways can this be done? So sometimes on the deployment you might see a little box. So anytime there's information to read that sets up the scenario, you get a little box. And above that box it says, use the following information to answer the next question. Or it might say, use the following information to answer the next 2 questions. Or even 3 questions, right? So they give you a scenario, maybe they want to ask you 2 questions about it. So it'll say, use the following information to answer the next 2 questions. In this case, that's what this would say, right? It'd be a basketball squad of 11 players to be chosen from 17 available players. This would be in the box. Above that, I would say use the information to answer the next 2 questions. And the first question would be, how many ways can this be done if Jeff and Brent must be on the team? Okay, permutation or combination?
Must be on the team.
Yep. Choosing 11 from 17, permutation or combination? Does the order we choose these 11 players matter? No, this is not the draft. If you're doing the draft, so you go to the hockey draft, and who's going to be the number 1 pick? Who's the number 1 choice in this upcoming hockey draft? Connor McDavid. Player, generational player, right? Guy that comes along like Sidney Crosby. Guys, he's the number 1, and he goes to Edmonton. Like, of all waste of talent. Like, seriously, Buffalo would have used him. Edmonton's going to kill him. So, okay. It's a combination. We want Jeff and Brent to be on the team. How are we going to handle this? So what are we going to say? What's a simple way of doing this? How many available players will there be? We got 17 available players. How many will there be if this is true? We have 17 available players. How many will there be if this happens?
Oh.
Okay, so there will be 15 available players. How many of them will we need? 9. Yeah, I'm gonna start switching to German. 9. So you can do it this way. There is one Jeff, and I need one of them. There is one Brent, and I need one of them. There are 15 remaining players, right? Because I want the top to add to 17, right? In this way, by doing this, we've accounted for the 17 players, right? One Jeff, need one of them. One Brent, need one of them. 15. 1, 15 is 17. 1 and 1, I need 11. I've already got 2 chosen, so 15, choose 9. Top adds to 15, bottom adds to 11. You don't work these out, they're just 1. Okay. Or you just write down 15, choose 9, right? Which is 5,005. What type of number is 5,005? It's a palindrome. It's a palindrome. No, it's a palindrome because it reads the same forwards or backwards.
Like Bob.
Like Bob.
Or Anna. Or LOL.
What if Jeff and Brent can't both be selected? Jeff and Brent can't both be selected.
So that, you can select one of them or?
Well, you tell me. So we need to do a case analysis, right? So what are the possibilities then? If they both can't be selected, what could happen? So, yeah, okay, so how many cases do we have to look at? 3. What are they? Jeff is selected, and Brent isn't. Or, right? Brent is selected and Jeff isn't. Or, neither of them. Good, we got 3 cases. So we've got the case where Jeff is selected and Brent isn't. So there is one Jeff and we are going to select him. There is one Brent and we are not going to select him. And there are how many players remaining? And how many of them do we need? So we've dealt with 2 here. That adds up to 17. This adds up to 11, so we need a 10 there, right? So this is Jeff is, and Brent is not. Or Jeff is not, Brent is. What goes here? Jeff is not, Brent is. Okay, same thing, 15, choose 10. Or, there are 2 players, Jeff and Brent. We're not going to choose either of them, right? So we can go 2, choose 0, right? Or you could go 1, choose 0, 1, choose 0. Whatever you like. And then what's left? How many players are left? From which to choose? How many players are left from which to choose?
11.
How many players are left from which to choose? And how many of those do we need to choose? Now comes the 11. Okay. And you work that out or you don't. Nobody cares, but it's 7,371. Okay. So they may not work it out, right? I mean, who cares? At this point, it's like, can you use your calculator? And we're not really interested in testing, can you use your calculator on this question, right? Can you recognize the setup of the problem? Okay? Yeah. Can you do an analysis? Can you recognize there's 3 cases? So I'd give you an answer like, actually, I'd probably leave out the 1, choose 1 and the 1, choose 0 and just say like 15, choose 10. Or I'd go 15, choose 11 is the way. Right, which would actually be the correct answer, 15, choose 11. But we could give you 15, choose 10. Oh, sorry. No, I mean the correct answer is adding all three together. So I give you 15, choose 10 as one answer. 15, choose 11 as another answer. 2 times 15, choose 10. Right? Or 2 times 15, choose 11. So you could get different answers in different forms. And you got to figure out how you're going to handle that. Oh, back up one sec. The other way we can do this is this. We know this is they are both on the team, right? So what's the opposite of they both can't be on the team? The opposite is they both are on the team. So we could also work out part B by saying 17, choose 11. That's all possible teams, right? Minus 5,005, minus this number. So this is all the possible teams minus the ones that have both of them on it. What if it doesn't have both of them? Then it has one of them or the other one or neither. Okay, so 17, choose 11 minus, so you don't have to do this, right? So that's another, they could put the answer like this, right? And you're looking going, I know it's got to be that. So strategy is you could work this out, get the 7371, and then start working out the 4 choices they give you that are going to look something like this, and say which one of those is 7371. Okay, and then that's the answer I'm going to choose. Okay, 2 more for those of you who are counting, which should be everybody. Quiz is on Monday and it counts. Well, not really until June, whatever, when you can no longer rewrite, at which point then it counts. How many arrangements of Okay, so how many arrangements of monotonous are there if, and we'll do 3 different scenarios, right? So you're not going to get 3 of these, like on the quiz coming up Monday, you could get 3 of these, right?
Monophones.
Yeah. There's another way to pronounce that. Yeah. I was putting the emphasis on the wrong syllable. How many arrangements of monotonous are there if A, no further restrictions? No further restrictions. Okay, what do we do? Permutation or combination? Does the order matter? If the order doesn't matter, then there's the one way to do it. Order matters. It's different arrangements. If you're arranging letters in a word, that's a permutation. Okay, how many letters are there up there? There are 10 letters, so 10 factorial, right? It says there's no further restrictions, just 10 factorial. Yeah? 10 factorial? Agree? Yes? No? Yes? Yes? This is why you guys always get these questions wrong. You don't have a clue. There's repeating letters. If there's repeating letters, we can't tell M-O-N-O if it's the first O and the second O, or if we replace the O's, right? If we start swapping the O's around, we can't tell. So we look for repeating letters. Does the M repeat?
No.
Does the O? How many O's are there?
4.
So what do we divide by? 4.
2.
Right. 4. Not 4. Although yelling that it could be on a golf course. Do the N repeat? Does the N repeat? How many N's are there?
2.
Okay, 2 and 2 factorial are the same, but you should write 2 factorial. Okay, O's are, does the T repeat? No, no, okay, that's it. So, please get this question right.
Oh.
Else I will be depressed in September when I come in and look and say, really? They just didn't get it. I won't be surprised, I'll just be depressed. You can't be surprised when you know the outcome. You could be depressed because you thought maybe you got through. I thought maybe. I can hold out hope. What if each arrangement begins with a T? What's the answer if each arrangement begins with a T? What do you do? What do you do with the T? Take it out. Toss it. Okay, what's the answer then? There's no T in there. It's mononymous. Okay, so the T is gone. So you have 9 letters remaining, of which 4 are O's. So you divide by 4 factorial. And 2 are N's. So you divide by 2 factorial. So it's 9 factorial over 4 factorial, 2 factorial. Okay, one last one. Each arrangement begins with an O. An O. Each arrangement begins with an O.
What? N-O. Haha. Get it. N-O. Yeah.
What it says. Each arrangement begins with an O. Okay, so what is it? What do? What's the strategy? Take out an O. So 9 factorial. Then there's 9 letters left. Over what? There are now 3 O's remaining, so there are 3 repeating letters, right? And 2 N's. So 9 factorial over 3 factorial, 2 factorial. Okay, for those of you that are still counting, this is the last one. But I forgot to mention there's 4 parts to this. No, there's 2 parts to this. A group of 4 journalists is chosen to cover a trial. So of course this was going to be a male-female thing, but yeah, it's getting old, right? So let's change this up. There are 5, what you call them, online or web journalists? What would you call it? Web. So there are 5 web journalists. And 7, what other media could cover this trial? News reporters. So let's say TV. TV journalists. TMZ breaks more news sometimes than CNN. So. And more accurately. And 7 TV journalists. How many possible groups can be formed if? Okay, and we'll just do 2 scenarios. How many possible groups can be formed if A, at least 3 web journalists Okay, so how many web journalists could there possibly be? You have to have at least 3 of them, and you could have, say something out loud. You could have 3 of them, or 4 of them, or no, because there's only 4 being chosen. Read the question, for God's sake. You have 3 hours to do this test. You know how long that is? It's 180 minutes. You know how many questions there are? 40. You know what 180 divided by 40 is? 3 3/4. You have 3 3/4 minutes per question. Some of which will take approximately 15 seconds to do. Like the sign one where it should take 15 seconds, right? And some of which will take 10 or 15 minutes. It's quite possible 1 or 2 of the puzzle questions might take you 10 minutes each or 15 minutes, right? It's okay. You have tons of time because the other questions are not all going to take you 3 3/4 minutes, right? Very unlikely they'll take anywhere near that. Okay, so when you see these counting questions, of which there will be many, right? First group that went through and wrote this exam, and I asked, how was it? There were so many questions on. Okay? Lump them all together. Set theory, counting, and probability, right? They can all be pretty much lumped together. Half the exam, set theory, counting, probability. Okay, so at least 3 web journalists. So we can have 3 web journalists. We have 5 from which to choose. If we do that, then how many TV journalists do we need? We need 1, because there are 4 to be chosen from a group of 5 and 7 is 12. Or, and 7 choose 0. You don't need to write the 7 choose 0. I kind of like to because it shows me that I've at least taken into account TV journalists. Okay, and you work that out, right? I don't even care what the answer is. B, at least 1 TV journalist. At least 1 TV journalist. So if there's at least 1 TV journalist, then how many could there be?
Yeah.
So there could be okay, so do we want to do that 4 times? So then what can we do instead? So what's the word for yeah, I know. The complement, right? Complement. What's the complement? Complement of having at least 1 TV journalist, which would be 1 TV journalist, or 2, or 3, or 4. What else is left? Complement is whatever's left in the set. So 1, 2, 3. We're choosing 4 journalists to cover the trial, right? And we're saying so at least 1. There's 1 TV journalist, or 2, or 3, or 4. What else is left? No TV journalists, right? So you could have, how many TV journalists could be covering this? 0, or 1, or 2, or 3, or 4. Now, I don't want to work out the 1, or 2, or 3, or 4. Instead, what are we going to work out? How many journalists do we have in total? So there are 12 choose 4 ways of choosing all of these journalists. What don't we want? We don't want 0 TV journalists. So if we take all the possibilities and take away from that all the possibilities where there are none of them, what's left? There's 1 of them, or 2, or 3, or 4. Now, I mean, luckily it's 30-2. You actually have time to work it out that way and do 4 separate calculations, trying not to make any mistakes along the way. Because it's a numeric response question, you'll have no idea if your answer is reasonable or not. Do it this way instead. Unless it's not numerical response, then the answer could be in this form, right? So that's why when we go through this, we're not just working out a number, right? Because the number may not matter. It may be the solution is expressed in this form.